and welcome to A.P.E. in Berlin, Germany. My name is Rita, and over the next few minutes I'm going to show you how easy it is to set up your LXSpider pulse measuring system. Like our pulse check autocorrelator, LXSpider lets you measure pulse durations with incredible accuracy. But what makes it more remarkable is that it also measures the group delay distribution of the pulse's spectral components in a single-shot manner. Because of this, you can do so much more. You can online view the true shape of the pulse, measure the chirp behavior, and access a wealth of additional information, all in real time. Here are the main advantages. First, you have direct access to the pulse spectrum, due to the built-in spectrometer. Second, the spectral phase of the pulse is directly measured. Third, the spectral phase is instantly analyzed with regard to dispersive contributions. Next, the temporal pulse shape is evaluated in real time by fast Fourier transformation. And finally, single laser pulses can be measured at low laser repetition rates. Nothing this powerful has ever been so compact and affordable, and it's easy to use. There are no buttons or dials or even a controller unit. You control everything via one software program. Setup is simple too. But before we begin, let me show you how LXSpider works, starting with the alignment step. One incoming beam passes through a series of optics to reach the splitting mirror. This splits the beam spatially into two separate beams. These beams are then tilted downward to pass through the nonlinear crystal. In alignment mode, a steering mirror reflects both beams into the alignment window. After alignment is complete, LXSpider automatically moves the alignment mirror out of the way. This allows the two beams to strike the focusing mirror, then merge at the entrance of the spectrometer for a sensitive phase measurement. For a robust measurement of the pulse spectrum, a diffuser can be turned into the initial beam path. Its innovative design allows for a more compact size and full automation. Once you've aligned the incoming beam, our software does all the work for you. First, open it by clicking the LXSpider icon. In the upper right corner of your screen, you should see a green light next to motors initialized. Then click the alignment button to set LXSpider in alignment mode. Finally, make sure the input aperture of LXSpider is fully open. You also need to ensure the beam is correctly pre-aligned. It should run at a constant height above the table, equal to the height of the input aperture. An additional alignment aperture can help you do this. Now you can put LXSpider in the beam path. Turn it into place until a double spot appears in the alignment window. You're looking for two half moons of equal size and brightness, one on each side of the crosshair. When that's complete, clamp LXSpider to the table to ensure it doesn't move out of place later on. As a final step, optimize the two spots in the alignment window by aligning the near mirror. When you're finished, click the alignment button. This will switch LXSpider out of alignment mode, so it will deliver the two up-converted beams to the spectrometer. Now we're ready to obtain the full information on the pulse. To do this, we need two data sets, and the first is the pulse spectrum. In the right column, check the measure spectrum box. Then use the exposure slider on the left to increase or decrease the detector sensitivity. If you prefer, you can also have LXSpider find the ideal level of sensitivity. Just press the auto exposure button. When you're ready, press the Save Spectrum button, followed by Confirm. Then uncheck the Measure Spectrum box. An interferogram of the fundamental signal should be visible in the measurement window. Now we can obtain the second data set, phase measurement. If this is your first time using LXSpider, if you've changed the alignment, or if you tune to a different wavelength, you'll first need to optimize the signal. First, make sure that auto exposure mode is switched off. To start, set the spectral range to second harmonic. Then tune the crystal to the correct wavelength by checking the Tune to Center of Gravity box. As an alternative, you can manually enter the center wavelength and press the Tune button. Be sure to reset the exposure time if needed. If you need to further optimize the signal, you can adjust the focusing mirror by using the hex key provided with your LXSpider. Here's how. On the right side of LXSpider are the 2 alignment screws for the focusing mirror. Use your hex key to adjust the horizontal and vertical tilt. The adjustment is complete when you've reached the highest intensity and best modulation of the green signal curve. The last step is to save the calibration. Again, our software makes it easy. Just activate auto exposure mode and set the spectral range to fundamental. Press the Save Calibration button, and when you're asked to replace the spectrum, choose No. Then return the spectral range to second harmonic. LXSpider will immediately show you the pulse in the spectral domain. The previously saved pulse spectrum will appear as a white curve, and the current reconstruction of the spectral phase will appear as a blue curve. You can evaluate the chirp of the pulse from the curvature of this phase. If you'd like to see the actual temporal pulse shape, click the Time Domain button. A second graph will open that displays the pulse shape at the Fourier limit in green, and the actual pulse shape as a white curve. The temporal phase is also shown. On the right, characteristic values of the pulse can be monitored, such as the pulse duration and the time bandwidth product. And that's it. Setup is complete, and you're now ready to start taking real-time measurements. I hope you found this walkthrough useful. If you have any questions or would like more detail, refer to your manual or visit our website to contact us. Our support team is always glad to help you. From all of us at A.P.E, thanks for watching.